In Chapter 17, we learn about SAS graph procedures. Very often, whenever you mention that you're going to do your graphs in SAS, there's a negative feeling about that, and I can explain why. So we'll deviate quite a bit from the book here for a moment. These SAS graph procedures have been around for a long time, and they're referred to as the legacy SAS graph procedures. And the statistical graphics we saw in Chapter 16 that are more of the ODS graphics are more current procedures and generate the ping files that I speak about in Chapter 16. We can use a lot of the color codes and some of the things that we saw in statistical graphics procedures and SAS graph procedures, and I'll show you how we can do that. But first, let's go to SAS. And we first open SAS. Let me put the help on top of SAS. When we first open the SAS help and documentation, a couple of things. First of all, the notation that I've used in the book, the uppercase, lowercase thing, that's what this SAS help and documentation does too. If you haven't gone to SAS help and documentation yet, you should. You'll be surprised at how much you can read. So there are various products within SAS, and so whenever I teach this course, I usually tell students that SAS is really huge. And so we're learning out of the entire body of SAS, we're learning like the little fingernail, okay? There is a lot going on in SAS. So just be cautious when someone says, can you program in SAS? Because you may know your area quite well, but you have to be aware of how large it is. When you first open SAS help and documentation, you get this contents, and so SAS products, just for a moment, if we expand this, there's this entire list of SAS products. And so base SAS is where we've been for quite a bit of our topics. Base SAS includes, we can see libraries in here, LibName. It involves a lot of things we didn't look at, but there are base SAS procedures such as the means procedure and the univariate procedure. Also, SAS graph, that's what I'm looking at here. And so in SAS graph, similar to statistical graphics, whenever you look at procedures in SAS graph, they have a G at the beginning of them. And so G chart, G contour, G device, etc. And so all these G means that they are part of these legacy graphics procedures that we call SAS graph. Well, fortunately, being able to produce graphics in SAS graph has gotten a lot easier, and we'll learn how to do that and manage just some graphics basics here. So we hadn't taken a look in the SAS help and documentation in one of the videos yet. We should. What I use most often in SAS help and documentation actually is this index tab, and then I switch this over to terms containing, and then I type in what I want to know about. And so if I want to learn about a procedure, so we had procglm, I can type that in and it'll search, and it'll give me some options then for the proc. Do I want the procglm procedure, that specific statement, and I can click on it and it comes back up here, and so I can move forward or back within these tabs within the GLM procedure and learn how to program additional options. So if you haven't taken a look at the SAS help and documentation, I encourage you to do that. Now, having said all this about the SAS help and documentation, now we'll move back into Chapter 17, our SAS graph procedures. So we're going to look at those procedures that begin with the G, that said our graphics procedures. So specifically, the ones we're going to talk about are Gplot, Gchart, G3D, and Gcontour. The rest of these begin with Gmap, and the rest we're not going to get into those. Those are require a little bit more time and expertise than we have here. We also want to talk about a G option statement. I didn't mention the option statement. It's also one of the things you can look up in Chapter 20 under the miscellaneous topics, but G options allows us to control a lot of information and appearance about our graphs. Before we examine the G options, I just thought I would show you kind of why SAS got a bad reputation for graphics. So this is not in the book. Listing output, if you write ODS listing, if you look at the ODS chapter, which is, I believe, chapter 19, it generates information down here in output. And so in this output tab at the bottom of the screen, the images that land here are text files, and so that includes whenever you write a graph. So notice we talked about proc G chart in chapter 5. We'll talk about G plot in this procedure, but here are the older versions of those. And if I were to run this, I need to enable the listing output, that is this window here first. So if I submit this, pardon me, I haven't declared the library yet, have I? Live name, we need demo, and I believe that's the G drive on my computer, and I'm missing a slash here. Now you saw some stuff flash by that didn't look very pretty, and even so it sends images to the results viewer and to the output window. So we'll look at the results viewer first. That's right, this is what G chart generates, and that just looks pretty horrible. Not production quality. If you look in the output window, it didn't get much better. Okay, so we have this bar chart just made up of different symbols, and so it's just a text file. Not at all what we'd like to see in the results viewer. We're seeing the same thing. This is the result of G plot, looking at the beef data set, carcass weight by dry matter intake. And so so whenever you say I'm going to produce my graphs in SAS, people have the image that you're going to produce these. And so that just hasn't been true for a number of years. So the advanced SAS graph procedures have been around for a long time. And so one of the things then first step is learning the G options. How can you control font and color and those sorts of things? SAS has various color naming schemes in the SAS registry, and so we're going to look at just the one that's referred to as SAS color names in this registry. And so if we want to look at what is the syntax to get this particular color, and so that there are some other alphanumeric codes for colors, and they're using a different color name scheme than we are. So if I just run this simple little program here and go to the log window, so what it did in the log window is it generated this column of colors. So anything that's on the left side here, the left of the equal sign, that's a color you can use in any of these SAS graph procedures. You're probably maybe limited by your printer if you're going to make hard copies of those, but you can put things into a PowerPoint presentation or other type of digital presentation and achieve a lot of different colors here. So you can get pretty crazy with some of the things here. So just by running this proc registry and get a list of all of these colors. It lists some other alphanumeric codes to the side. These are other color names, and so we're just going to work with the text. It doesn't have to be this uppercase, lowercase, but you'll notice when you have more than one word, such as Misty Rose, and there's no space in there, so you want to make sure you put those all together. Okay, so clearly we can look at many colors. Now, for the book, I was limited in what was compatible with a black and white or grayscale textbook, and so that's why everything's done in black and different colors that adapted well to that grayscale. So you see silver, light blue, grays, and that kind of thing for my color choices in the book, and that's because I was limited to those colors in the book. But as we go through some of these objectives, you can change this up any way you like. I mentioned the options statement that appears in Chapter 20. There's also a G options, which means graphics options. And so you can change the color of your text. And so that any one of those colors we just saw from the SAS registry, we could put here. This is going to be the color of the title, any axis labels, any tick marks. And so all of that's going to be set by this C text. Option here in the G options, you can choose a font, and so there are some built-in fonts that are SAS specific. So the ZAPF looks a lot like Times New Roman, which is what the book is written in. So if you this font with serifs, and then you can look also at some true type fonts, and this is very dependent upon the platform in which you have installed your SAS software. Heights of text. Do you want big letters, little letters? So you can take care of that and by specifying this. The default height is 1, and so if you want something to be 50% larger, you write 1.5. So those are just a few of the options. Those are global options, so they affect the text, the color and font will affect any titles or footnotes you select as well. And so remember, titles and footnotes are global options, and then there are also graphics options, and so that those are in place until you close the SAS session or until you change them. And so there are some resets you can do. G options reset all. That includes all the global and all the graphics options. You can just choose to reset your graphics options or the global options, such as your titles and footnotes. So as you go along in the book, we've picked up a few tools. So there's usually at the top of my programs, I have a little housekeeping I do. So I put in a display manager command so that I can clear the windows. For this project, I clear all existing lines of title and footnote, or you can just put in a G options reset all, so that way if there are any fonts or anything lingering from a previous program for those kinds of selections, all of those are taken care of here. Some of the also housekeeping things that may be at the top of your program may be live name statements if you know you're going to be using a permanent SAS data set, or file name statements. Also, any miscellaneous comments that help you identify the project or the client for whom this is you're presenting this or working on this project for, you can include all those as either single line comments or block comments as demonstrated in Chapter 20. In Chapter 5, we learn the G-chart procedure, and so that's where you'll need to review that a bit before going here. So in terms of the chart statement types, you want vertical bar charts, and we saw that using proc chart. But now if I want to dress that up a little bit, like I said, for the book I used light gray. I don't believe there are any options in the syntax shown for Objective 17.1, but we can change this up any way we like. So here I had light gray. If we want to change things over to dark red, we can do that. And so all of this top information, I can grab all this and run it. And I can change up the way the bars appear. I've already shown you the registry here, so we don't need to go any further with that. And so that you can fill in what we could not do back in Chapter 5 because we didn't know all this color option. Remember, I talked in Chapter 5 about we'll learn to change these colors later. It's later. Okay, so we want to look in the G-chart procedure here, and so we can choose different colors. And so my title here in the book matches the pattern statement that I use, and so that if we keep going with some of these, I wanted the black X. So what was the difference between these two charts? Up here I did select a color, and I can choose solid bars, or I can choose this X pattern. You can look at 3D charts. So I chose here a silver color so that it worked with the book. Again, you can choose whatever you like whenever you're looking at some of these. So you can either do solid bars or an empty bar where you do an outline when you do 3D. Just because we can do a 3D chart doesn't mean we should, and it's something I've long stated. So that is the effect of a 3D chart. keeping the color the same. And in objective 17.2, and notice we've got proc G chart, and we can have multiple chart statements as long as we separate those by a run. The title that's there will go forward. Pattern statements are global, are for the graphics, and so the patterns are active until you change them. And so this is just a side-by-side comparison of what solid bars look like, what we call an empty bar, and now X3. We saw the X1 up above. And so this is again a vertical bar chart for producer, where the height of the bar is the mean ribeye area, and we're going to change the patterns with every color of bar. So where is the midpoint? That's where we're going to change the pattern. And so that's what, and we're also going to do this with a Times New Roman font. Alright, so if I scroll up here, you can see the font that SAS uses here. The default font is called Simplex, and so that if you want to change it up to match your document or other items in a presentation, so you can see the change in font here, it gets a little smaller. I said for every value of the midpoint, change the pattern. So this is what we mean by black solid. A black empty means it's a black outline, and then there are 3 lines for each half of the X here, and so that's an X3 pattern. So you can do X1 through X3. X1 through X5. There are also diagonal line patterns, R1 through R5 and L1 through L5 as well. So when you look at these, it's producer. Each producer has a different color bar. You can apply that different color bar to the producers. So here they were grouped by sex. Remember, producer 1 did not have any heifers, and so there is no black bar for producer 1 in the heifers group here. And so that again, the producers, you can track your colors or your patterns with determined by the value of the midpoint. If you group by producer, and then you have a bar for each of the values of sex, so that you still have different colors for each producer, and so the syntax shows you how to do that. So again, you could change all of these up and for the colors to work whatever your presentation method is. In the next objective, we reset our title and our pattern statement. So pattern semicolon resets just the pattern statements. I want to make the fonts a little bit bigger. Notice they were a little bit small when I switched to Times New Roman. And then here's a new option for us: subgroup equals sex, and the pattern ID is subgroup. So pattern IDs can change from midpoint. They can change based on the group, or they can change based on subgroup. And so that when I go through and I'm going to look at these two together, subgroup breaks the bars up into pieces. So the subgroup was the producer. Notice it put a legend down here. My font is a little bit bigger. It's still Times New Roman. That was the second one. Here the producers run across, and so here I had the subgroup was sex, and then if we go back to the code, it says the pattern ID changed for each subgroup. Okay, I can put the comments out here to the side as a reminder to myself what these bars represent, or what these colors and patterns represent. You can change the font. Swiss looks like an Arial font. B is Swiss bold, and so you want that a little taller, and you can make pie charts. The pattern statements apply to pie charts. Each slice of the pie is referred to as a midpoint also, and so that we can look at the different patterns associated here. Where do we want the values printed, inside or outside of the pie? And so you can, if you have numeric values for a pie chart, you also need to use discrete, because otherwise it will choose perhaps a value for the number of slices that you don't want. And so that we can look at pie charts then the first one here, so it labels it percent of producer. That's the heading for a pie chart, so that no heading option, we'll turn that off. And so you can just use the title to label things how you like. And so out of our beef 3 data, this is looking at the percentage of animals that came from each producer in that data set. That was percent. Here was the actual number or frequencies of animals. And so if you turn that header off, you need to make sure you have the labeling and the titles or footnotes that help you identify that information of the graph. Also in between those, everything was inside. Out here you had the level outside and the percentage inside. The G-plot procedure, what it does is plot an XY coordinate system, and so we're just going to deal with producer 3 here, and we're the images, so you can choose the plotting symbol and the colors of those. Again, you can make those any color you want, so I'm going to change some of these, just differ from the book a little bit, resetting my lines of title. To do this, it's not a pattern statement but a symbol statement, and this is objective 17.5, so we're looking at carcass weight by dry matter intake. We're still with the Swiss bold font, and so here I have the solid orange dots for my data. Notice the labels for the variables appear on the graph. If you have a very long label associated with the y-axis, it's going to tend to push this to the right or compress your graph if it were very long label. So this looks okay. There are ways we can change this, where we can take this carcass weight and rotate it and run it then so it appears at 90-degree rotation from where it's presently at. Now the previous chapter, some of these graphs we're doing in this chapter I also did in the previous chapters, just show you there's more than one way we can do things. And so we had looked at, for each producer sex combination, producing the means for those, and then we wanted to graph those. This is what we would refer to in the statistical analysis as a profile plot, or perhaps an interaction plot, where you can generate a different line style for each of the sexes in this case, and then you can also figure out each of the producers. And so that there are some options that I look at here. So line styles, you can choose one up to 42, 46 different line styles that you can experiment with. You can also make your plotting symbols larger, and so that if I wanted to, the value equals none in the graph, notice there's no point in there, and so you can make the lines a different color than the plotting symbols. If you don't specify a line color, it uses the color value. C is the color of the line. You can make the height of your symbols a little bit bigger. You can make your lines a little bit wider. Okay, so I made the dots here, they appear a little bit bigger than they did below, and then this line I've made a little bit bolder by putting W equals 2. I can put both of the lines, perhaps I can write both of those a little bit bolder. Again, if you're going to be reducing things in a presentation or in a publication, if you're going to know it's going to be reduced, you may want to make lines bolder. You may want to make fonts larger or bolder. So I didn't point out the angle of rotation on this now, so that looks nice. I probably wouldn't keep this. An advice to you when you're getting ready for making your graphics for your final, either a PowerPoint presentation or for your paper, I would pull the titles off, because you're going to want to move things about in your presentation or in your paper, and so that just use your software for the presentation or for the paper to create the titles there, as would be what I would suggest. Again, you can match your fonts to that. You can change up colors. any of the images we have here. If I right click on it, I can save this picture, and it tells me it's going to save it as a ping image, and then you see too much about my computer right here, so I better close that. But you can look at making things more specific than to match your particular project presentation. Legends were generated by some of these procedures whenever there were multiple variables within the same bar, whenever we were looking at some of the plots. And so you can choose legends. Let me scooch up here a little bit. So legends, legend statements are like the axis statements. You can define them, but they just exist until you call one of them in. So you can say, I'm going to use legend 3. So here I've just created 5. The position I want this is at the top inside of the graph, and then don't label anything. Okay, top right outside. Default is going to be centered, pardon me, bottom outside center. And so I give you in one of the tables in chapter 17, pardon me, I give you the different choices you have in creating a legend, and so that you can be in control of the legend. So like all of these procedures, for all of the procedures, I do give you a table such as the one here on the screen for legend statement options that tells you allowable syntax. So I have this for patterns, for symbols, for the axis statements and how you call those in. And so you learn at what the options available here are. So it tells me what things I can write here, and for each one of these things I can pick one. It's either at the bottom of your graph, in the middle, or the top, and we go through some different objectives where we can move that around, and you can see what the appearance of the legend then changes. And so we have quite a bit of control then over the legend, or if we want to suppress the legend altogether, we can do that, so that where we would just write no legend. Now, depending upon the length of the variable you have or what these values are, this legend again can compress things quite a bit, and so you want to be careful then where you position the legend. If you wanted to do an inside legend, that would be inside the axis. There's a lot of space in here, or the default position underneath the word producer here, centered. And so this particular Objective 17.8 is demonstrating the legend 5 that I defined, and so experiment with those, experiment with the different colors. There's just a lot of cool things we can do with the graphs. I think any analysis can be enhanced by a good graph. There are a lot of ways to make a bad graph. There are a lot of ways to make a good graph. And so I think once we kind of get some of the SAS graph and the statistical graphics procedures figured out, we can make a good graph. And so the procedures, univariate and GLM, they were producing graphics as support for the analysis, and those are in that class of ODS graphics, of which statistical graphics is a part. We can look at multiple plots per axis. The idea that we want to overlay items, and so the actual option here is overlay. So you can plot here n different variables on a vertical axis by an x variable or horizontal axis, and you say that you want to overlay those, and then you have a legend so you can tell those apart. For every variable here, 1 through last, you need a symbol statement so you can tell those apart. There are some special cases where maybe 2 of the variables can use the same symbol statement, but you want to define n different symbols for each variable that you're placing on the vertical axis here, provided this is staying the same value down here. So don't forget the overlay option. Without the overlay option, you're going to end up with n different XY coordinate graphics. When you have items you want to overlay and their axes don't align the same, you may want to use a plot to statement, so that the plot statement will generate the left hand vertical axis. The plot 2 will be correspond with a right side axis, and so you can use a legend for either one or both of those plots. And so we can demonstrate this with again, the Beef3 dataset in the demo library. And so if you want to look at scatter plots of ADG by ribeye area and DMI by ribeye area, I'm selecting only producer 3 so that the graph does not become too congested, and I have it done in 2 different ways. So we reset all graphics options, and then we set our font equal to the ZAPF, or as close. It also looks much like Times New Roman. I have the options of making that bold and italicized very easily, though, if I would want that. My legend, I want to keep it. Usually you run a graph first, find out if you have some blank space that it makes sense to put the legend. And so I don't want to label my legend, and so I have here axes 3, 4, and 5, and so how those are defined. So I know I'm rotating a label here, and so that's going to be the first one. Axis 3, I'm rotating the label, and then for axis 5 is on the plot 2 statement. So we'll go through this one in a little more detail than the previous one's objectives in this chapter. And one of the things we can do then is, since we have here, we have a circle and dot, let's mix it up a little bit. Let's call something red. And we can tell things apart, but the circle and dot are kind of opposite of an open circle and a filled circle, so that if you are limited to black and white, you can see that. So I've got legend 1 up here, top inside, and top left inside. If I don't specify, it's going to be center. So let's see what we get when we get these. We're using both legend 1 in the first plot, and in the second part we're using legend 6 and also a legend 1. So let's go through and see what we have. Okay, so in the first one we did an overlay option. Okay, a few things going on here. So I have then ribeye area down here, and I have the average daily gain is the open circles. Those tend to be 2 to 3 pounds. So we see all that down here, and then the dry matter intake much larger, and we can see a positive trend here. We see these small values over here for ribeye areas. There was an animal in there that was quite small. For reasons I don't know, it was kept in there, but when you see something like this, though, also, and there's a chapter 20 section 2, is this data value correct? And so doing a simple gplot can show you if something is much different, and so that we could do a search then for what is the value that produced, or what is the line of data where this was recorded, and so we could double check it to make sure it's accurate. Okay, the problem with this is because we're putting ADG on the same scale as dry matter intake, this is very compressed, and so to me this doesn't look as informative. So that would be a reason that you'd want a second plot. So whenever you overlay things, you want to make sure that the shared axis, this ribeye area, was the same for both, but these two responses aren't well represented on a 0 to 30 axis, and so this is like very compressed, and so that's one of the motivations for using plot 2. Okay, so I put the index inside here. Over here it's average daily gain. That's that 90-degree rotation for ADG. Average daily gain here, I said 2 to 3 pounds. We've got some of them that were actually quite high. But anyway, so we're seeing that scale here. I could control this scale with an axis statement. Over here in plot of the dry matter intake, this was the 270-degree rotation to get it on this side. And so the red responses are dry matter intake, and that's what I use look at over here. So we can see the very close association between these two, even though they measure on different scales. So things you should experiment with that I would encourage, since you can, is that you can change up your colors You can change your plotting symbols, change your fonts, and so there are things that I ask you to do in the assignment that are specific, and so you of course want to get that done. But in your own presentations, then you can make some choices. Back in Chapter 16, we had some different things for marker attributes and line attributes where we could select color. The SAS registry I talked about at the beginning of this video, those color names apply to the SG procedures as well. And so that if you want to go OSU orange, you can. If you have another school or team and you want to do work with those colors, I'm sure you can find that in the list of available colors in the SAS registry. Next time we'll talk about three-dimensional graphs, and those look pretty cool. That's all for now.